This is the end behavior of polynomial functions. It is the behavior of the graph f of x as x approaches positive infinity or negative infinity. And how do we identify the end behavior of the graph? We simply look and identify the degree and leading coefficient of the polynomial function. Now let us first see the graph's end behavior when it comes to linear and quadratic functions. Linear function. These are the two examples. Both of them have the highest degree 1, which is an odd number, but they differ in signs of the leading coefficients. The first one is positive x, and when plotted, this is how it would look like. It is increasing because the value of a, or the value of the leading coefficient, is more than 0. And then the second example has a negative value of a. Therefore, when plotted, it is decreasing. Next are the quadratic functions. These are the two examples of quadratic function. They both have the highest degree 2, which is uneven, and again, differ in signs of the leading coefficient. The first one is a positive a, so when plotted, it would look like this. It is a parabola that opens upward. How about the next example? It has a negative leading coefficient, and when plotted, it would look like this. It is also a parabola, but opens downward. Let's move on to polynomial functions where the degree is higher than 2. It can be 3, 4, or 5. Okay now, guys, remember the code PENEPONO. P-E-N-E-P-O-N-O, where P refers to positive leading coefficient with an even degree and will look like this. Next is N-E, where it refers to negative leading coefficient with an even degree and will look like this. The third one, P-O, which refers to positive leading coefficient with an odd degree and will look like this. Last but not the least is NO, where the leading coefficient is negative with an odd degree and will look like this. Let's get into the examples. First, f of x is equal to x raised to 4 minus 6x squared plus 3. The leading coefficient is a positive, while the degree is an even. Therefore, it is a PE. And when plotted, here's how it would look like. It rises on the both sides. It rises on the left and it rises on the right. Second example is, the f of x is equal to negative x raised to 4 plus 6x squared minus 3. The leading coefficient is a negative, while the degree is uneven. Therefore, it is an NE, and when plotted, this is how it would look like. It falls on the both sides. It falls on the left and it falls on the right. The third example is, the f of x is equal to x cubed plus 3x squared plus x minus 2. In here, the leading coefficient is a positive and the degree is an odd. Therefore, it is a PO. So when plotted, here's how it would look like. It falls on the left and it rises on the right. The last example is, the f of x is equal to negative x cubed plus 3x squared plus x minus 2. The leading coefficient is a negative and the degree is an odd. Therefore, it is an NO. So when plotted, it rises on the left and it falls on the right. And that's the end behavior of polynomial functions. A big shout out to Greg and Penny for letting me draw their characters here in this video. And if you didn't notice, here they are. This is Greg with his ointments, and this is our very beautiful Franny. Well then, thank you very much for watching, and remember, stay awesome. Well,